I just came from a long run and I have completely run out of energy. And I am very, very tired. And I need food to refuel me. Well, since we're already talking about energy, let's get to know more about energy and its types. Energy, an integral part of our lives. What is energy? Well, energy can be defined as the ability of a body to work. We all require energy to work, and our world only exists because energy changes happen. And when these energy changes occur, things happen. The law of conservation of energy states that energy can neither be created nor destroyed. It can only be converted or transformed from one type to another. Well, why do we need energy? We need energy to work. Energy is necessary for us to even do as little as move our hand. And other things also require energy to function, just like the streetlights or the fans in our houses. Where can we find energy? We can find energy everywhere in various different forms. Like the sun outside gives us solar energy, which is a mixture of light and heat energy. When we eat, our body breaks down food and stores it as potential chemical energy so that we can use it later on. The cars that we see on the road, they move, and so they have kinetic energy, which is also known as the energy of motion. Lastly, is energy and force the same? Well, no. Energy and forces are different because energy can be defined as the ability of a body to work, whereas force is just a push or pull of an object. And we require stored chemical energy to apply force on an object, and we can only push or pull when we have that stored chemical energy in our bodies. Therefore, they are different.
Hello everyone, my name is Sal, and now I'm going to explain you the types of energy. So, types of energy plays an important role in this section energy, because without knowing the types, it's impossible to convert one type of energy to another. So, it's kind of obvious. Now, let's start with heat energy. So, heat energy is an energy which provides heat to all the three matters, which includes solid, liquid, and gas. So now let's take an example by seeing the picture shown in the right side. So at first we can see that solid is getting heated by fire. So when the solid gets heated, that time the thing which happens is the molecules inside it starts vibrating. So eventually the vibrating molecules start moving, which means the solid has converted into liquid. And then when we heat the liquid, that time the thing which happens is the inside particle starts moving more randomly. So that time we can understand that the liquid is converted into gas. So heat energy is also known as thermal energy, and heat energy always becomes or spreads as hot to cold. Means when it gets heated, that time it's actually hot, but when it's not heated, that time it's actually starts to get colder. So heat energy is spread to conduction, convection, and radiation. And another important thing is gas has the maximum amount of heat energy. Now let's go to the second one, which is kinetic energy. So kinetic energy is kind of easy. It's actually movement of anything, movement of something. So the amount of kinetic energy depends on its speed and mass. So if you look at the pictures shown in the below, we can see a person is running. So here there is movement of the person, means there is kinetic energy. Then in the car is moving. So there is movement of the car. So there is also kinetic energy. And the second point, the amount of kinetic energy depends on its speed and mass. So an example can be actually when you drop off one tennis ball and a football from a hill downwards, that time means from top of the hill, that time which ball will go faster. So the answer is the football, because it has more mass, so it will get more force than the tennis ball. Now let's go to the sound energy. So sound energy is the energy which provides sound to us. Means sound energy is all the sound we get to hear around us. So let's take an example of the speaker. So when the part from where the sound comes from the speaker, when it vibrates, that time the air molecules around it also starts vibrating. So when it goes into our eardrums, that time our eardrums also start vibrating. So our inner ear translates the vibrating sound into messages to our brain, and we interpret it as sound. Now moving on to the fourth one, which is the light energy. So light energy starts from the light rays. So the light rays gets focused by our lens, and then it enters onto the retina. Then it is converted into messages which our brain uses. So together, light and heat energy from the sun produces solar energy, which we often use nowadays. And then bright light has more energy. Now the last one for me, the chemical energy. So chemical energy is kind of a stored energy which actually gives energy to various things by converting it into other types. So let's take an example of the car. So the car is storing petrol in it, and the petrol has chemical energy. So when the car uses the petrol, means the chemical energy, that time it gets the energy to move. So that time the chemical energy is converted into kinetic energy.
Now we are going to learn more about the different types of energy. Potential or stored energy, gravitational potential energy GPE, electrical energy, and nuclear energy. Potential or stored energy is a form of energy that an object possesses by the virtue of its position. There are various types of energy, which includes elastic potential energy, which is stored in elastic materials such as springs, rubber or elastic bands, etc. Chemical potential energy is the energy stored in objects which are made with chemical components or atoms. Gravitational potential energy GPE is the energy in an object which is mass, gravitational field, and height above surface or ground. Now let's only focus on gravitational potential energy. GPE is the energy within an object due to its mass and distance above the ground. If given the chance, gravity will make the object fall. That time, GPE is turned into kinetic, moving or motion energy. Gravitational energy is energy stored in an object's height. The higher and heavier the object, the more gravitational energy is stored in it. Electrical energy. Electrical energy is caused by moving electric charges, also known as electrons. The faster the electrons move, the more electrical energy they carry. Electricity is the movement or flow of electrons from one atom to another. This flow of electrons is called current, electric current. Electrons can move through any materials, but through conductors, they can move quickly and easily. Again, insulators are such materials which obstruct electrons to flow from one point to another and doesn't conduct electricity, etc. Nuclear energy. Nuclear energy is the energy in the nucleus or the core of an atom. The nucleus of an atom is dense and is held by immense amount of energy. Also, it contains a huge amount of power. Nuclear energy can be used while producing electricity, and the radioactive materials needed while generating it can further be used for industrial, agricultural, medicinal, and household purposes. Nuclear energy can be extracted from an atom in two methods, nuclear fusion and nuclear fission. In nuclear fusion, atoms join together, and in nuclear fission, atoms are split apart. However, nuclear power plants do not have the capability of producing energy from nuclear fusion safely and reliably. For this reason, uranium pellets are used to produce nuclear fission. The nuclear reactors forces the atoms of uranium to break apart so that the splitted atoms can release tiny particles called fission products, which can cause other uranium atoms to split and start a chain reaction. The energy released from the chain reaction creates heat, which warms a cooling agent, usually water, and steam is further produced. The steam turns on turbines, which then drive generators that creates electricity.
Energy transfer can happen in many ways, much of which we can see in our lives. Reading a book does give us some ideas about a topic, but we can understand the topic better if we can relate to the topic. So now, let's relate our understanding about energy, law of conservation, and different types of energy to see how we can see energy transfer in our daily lives. And we will be taking our phone, for example. At first, we use the electrical energy from the mains to charge up our phone. Now, by charging up the phone, I mean that we give energy to the batteries so that it can work. Our batteries inside the phone take out the electrical energy from the mains and turn it into chemical potential energy for the phones to work. So, when we use the phone, you might have observed that a lot of light comes out from the screen. So, here light energy is being used. Oh, what happened? Friends, did you see that when we use the torchlight option of the phone, that time light energy is also being used? Oh, sorry friends, I just got a little bit distracted over there. So, as you have already seen, that when we watch any videos, that time sound can come from the videos. Oh, and also when there is a ringtone or an alarm, we can also hear the sound. So here, sound energy is also being used. Question for you. Can you spot any wasted energy here? If you think that it's heat energy, then yes, you are correct. You might have observed that when you use your phone for a very long time, or if you charge it for a very long time, then it will get really hot. This energy is heat energy and it is wasted here because it's unnecessary. Now we got to know about the energy transfer in a phone, from electrical to chemical potential to light, sound, and wasted heat energy. But this is not only applicable for a phone, but it can be also seen in various other devices, such as in a TV or in a laptop.
Good morning, dear friends and teachers. Today I'm going to be talking about energy transformation. Did you guys know that energy could be transferred from one device to another? It happens when there's a change of energy within the device. I'm going to be showing you some of the transformation in depth diagram, but first of all, let's get a quick example. For example, in an electric water heating pot, electricity heats up the water. Here, electricity changes into heat energy when the water is being boiled. But not all the times that the energy is useful. Sometimes it is wasted energy, like when a TV is running, but the batteries are getting heated, and that is wasted heat energy. Here are some examples. Laptop's batteries have stored chemical potential energy, which helps the laptop to turn on and be in use. The light energy. The light that produces is light energy. Sound energy. While we're watching a video or doing something or having a call, that time the sound it generates is the sound energy. But the batteries are getting heated, so that is wasted heat energy. Cordless drill. Cordless drills also have batteries with stored chemical potential energy, which helps it work. Kinetic energy. So when the drill or the screwdriver rotates, a circular motion is created, causing the kinetic energy to take place. Wasted sound energy. It causes a lot of unnecessary sound, which is wasted sound energy, and also the drill might be heated, which is wasted heat energy. Handle game console. The batteries can have electrical or chemical potential energy stored. The light energy. The game console gives out light so that we can see the screen and play the games properly. Sound energy. While playing, the game can have different sounds at different times, so the sound energy is also present in this device. But also the batteries are getting heated, which is wasted heat energy if you're playing for a long time. Electric toothbrush. Electric toothbrush has chemical potential energy in the batteries so that it can work properly. The kinetic energy, when the bristles are moving automatically, kinetic energy is taking place. The sound energy which it causes releases a lot of unnecessary sound, which is also wasted sound energy, and heat energy that it sometimes it might overheat and burn, which is wasted heat energy. Thank you.